Hi friends, this is I welcome you all to this video. I hope that last three lectures was useful for you, and I hope that the previous video will help you to know how to draw the auxiliary views drawing projection of auxiliary views. Okay, so as I discussed in the previous video, in the same way only in this video also we are going to see one problem 2. In previous lecture 3 I have shown one problem 1. So here we are going to show the problem 2 or second drawing. Okay, so let us go to the video. This is mechanical engineering drawing. The code is 1625302 as per the SPT Bihar, and this is the one small GIF file. It will explain you what is the auxiliary view. Okay, how we will draw it. Okay, how we will draw. Just this is the front view, side view, and plane view. Plane view means plan view means we will square as a side view, top view. Okay. Okay. Now this is my fourth lecture, and the same auxiliary views drawing we are going to see. And myself, I am Arun Pandian, lecturer in mechanical department of GEMS Polytechnic College, Aurangabad, Bihar. Okay. So we are going to see the content. What content we are going to discuss or we are going to see in this video. Same drawings on auxiliary views projection. Get ready to draw. So we are going to draw, get ready, take your protector, scales, pencils, campers, whatever you want, just take it and get ready to draw the diagram. Okay. So problem 2. Already in previous video I have discussed the problem 1. Here we are going to see the problem 2. What is the problem? Same. Okay. So in previous video also we see now on hexagonal prism. So here also the same hexagonal prism we are going to see. Just go ahead. Okay. So hexagonal prism, side of base 25 mm and axis 60 mm long, lies with one of its rectangular faces on HP. Be careful. Lies with one of its rectangular faces on HP. So rectangular faces, one which will lies on HP. That point is important. Keep that point on your mind. Okay, such that the axis is inclined at 45 degree to VP. So VP already you know it is called as front view. So 45 degree I have to draw from front view. Draw the projections. So we are going to draw the diagram drawing. In previous video I told, first of all, when you read the problem, write the given data first and then start to draw. That will be easy for you. So whenever you are whenever you are drawing, you can just look at the given data and you can draw the diagram easily. Okay. So now given data. What the data are given on the problem. So if the drawing sheet, if we have the drawing sheet, just on the back side of the drawing sheet, write it the given data. What data are given on the problem? The first is, it is an hexagonal prism. So first look at the sum and write it on the given data. First it is hexagonal prism. Second one, the base is 25 mm. The base means the hexagonal base, every sides are, the length is 25 mm. And next, axis length is 60 mm. The length of the axis is 60 mm. And next, lies with one of its rectangular faces on HP, top view. Okay, so we are going to draw the rectangular faces of hexagonal on the top view. So if the rectangular faces is in the top view, the hexagonal will be on the front view. Got it? Can you understand? The rectangular face in hexagonal prism, if you see from side or how you are keeping the object, it depend upon that. If it is extruded, it will look like rectangle in each and every side. If it is extruded, so that is on top view. So the hexagonal will be on the front view. Can you get the point? So now axillary inclined plane is 45 degree from front view. I have to draw the 45 degree angle from the front view itself. I have to draw. So again, I'm reading the given data once again. It is an hexagonal prism. The base is 25 mm. The length of the axis is 60 mm, and the rectangular face is which lies on the top view, HP, horizontal plane. So that the hexagonal will be on the front view. Okay, so the hexagonal will be on the front view and the rectangular faces will be on the top view. And last one, the axial inclined plane is 45 degree from the front view. Okay, so now, I want to show you how the hexagonal prism will look like. Okay, in previous sum also same hexagonal prism, but it was on vertical. Now it is horizontal because of in that the sum was different. Okay, it was given the sum was different. Here it is mentioned as the parallel, or otherwise the hexagonal prism. The sum is given that the rectangular faces lies on HP. So in the top view, the rectangular faces must be there. On from front view, the hexagonal shape must be there on the front view. So as per our previous class, I have already explained how I have to see this is the top view and this must be the front view, because I cannot put the eyes here. That's why I put the eyes here. There, because of we are not going to draw the side view here. So that's why consider this one as your front view and this one as your top view. So see how it could look like. So it is rotating now. Okay. So I will explain to you when it's come in a right position what view it is. Okay. So now it is a right position. This is the front view. Okay, I'm telling this is the front view of this drawing. We are going to ask for the sum. This will be the front view, and as per the sum, this will be the top view. Got it? Again, I'm telling, as per the sum, let it maybe come. Yeah. As per the sum, this will be the front view. As per the sum, let it may rotate. Okay. As per the sum, this will be the top. Got it? So now we are going to see with the using of the 3D shapes how we are going to draw the diagram. Okay, so see here, this is the top view. As per the sum, we are going to draw a top view like this only by using on the 2 dimensions. This is a 3D shape, but we are going to draw the 2-dimensional view. Okay, and this will be the front view of the diagram, and if it is inclined 45 degree from the front view, it could look like this, but not exactly 45 degree I given. Just for an imagination, I have given a example view here. Okay, I just given an example view here how the 45 degree inclined view will look like. Okay, so see guys, if you are seeing this will not give on your exams. Okay, if you go for any exam, this will not, because if you imagine like this, if you start to imagine, okay, this is the hexagonal prism. If I look it from top, how it could look like. If I look it from side, how it could look like. If I look it from top, how it could look like. Okay, so like this, if you started to imagine, so this is the best idea. I will tell you that is the best option for you to draw the 2D shapes easily. Okay, you can draw the 2D shape easily when you came to know the real shape of the real 3D shapes of the given problem or given shapes, hexagonal or cones or pentagonal, whatever it may be. Okay, whatever it may be. So by keeping this all ideas, if you have in your mind how the 3D shapes will look like, if you know the 3D shapes, you can draw the 2-dimensional view very easily. Within a fraction of seconds, you can finish it very easy. It is possible. Okay, so to keep these drawings on your mind. Okay, what you are seeing now in the view, this is a 3-dimensional view of the hexagonal prism which you asked for the problem given. Okay, and now we are going to, okay, so this is the inclined axial inclined plane of 45 degree. If the same prism is inclined 45 degree, how it could look like? This diagram we are going to draw. So now we are going to see the diagram. So next 10 minutes, just concentrate on the complete video, step by step. I'm going to teach you. Okay, same as like a previous video, step by step I'm going to teach you. So just look at the video and you can understand it very clearly. Okay, first, as usual, draw a XY line. Okay, this is the X and this is Y. Draw a XY line on the drawing sheet. Okay, so I'm explaining you. If this is a drawing sheet divided as a 4, here front view, top view, side view, and the main contents means what is your name, registration number, drawing name, sheet number, scale. This are all you have to put it here. But here we don't have side view. In the place of side view, you will draw the inclined face of axial inclined plane of the object. Okay, so these are the main concepts. So just keep it in your mind. So this must be regular in all the views. Okay, so first draw the XY line. Next, already I have told you the base lies on the HP. It is given on the sum. Okay, the base lies on the HP. So it must be on the if the rectangular face lies on the HP top view, then the hexagonal must be on the front view, vertical plane. That is all. The problem, it is given as the rectangular face lies on it horizontal plane. So horizontal plane means already you know it is a top view. So if the rectangular faces of the hexagonal prism is on the top view, then front view must be the hexagonal shape must be on the front view. That is a different. Okay, and after drawing, put the center line, and this is the vertical plane or the front view, and the bottom will be the horizontal plane. Okay, and now start to draw a line from top. See one thing which is given. Okay, the details about what is given, that must be the main. Okay, so that must be the main. Okay, and from next, from top to down, center line, draw the center line of the object. Then again top to bottom, then again from top to bottom draw a straight line. Okay, and now here we are going to draw the rectangular faces of the hexagonal prism, 6 faces. So we can see this 4 faces only. So the drawing will look like this. Straight line, straight line, and straight line. Okay, so see, each and every drawing, I'm not drawing with the correct exact dimensions. I'm just drawing roughly. So when you draw with the right dimensions, the drawing will come some different. It will not come same as like this. Some different may be there. Okay, so don't worry about the drawing is not looking like this. My drawing is coming in different way. Don't worry about that. I have drawn in this, not in exact dimension. I just roughly have drawn how the drawing will look like. Okay, and next mention the points 6, 1, 5. It is the 5 is on the bracket. Why? Because of I cannot see it. It is on the back side. So next P, and 2 bracket 4 I cannot see. That's why 4 is on the bracket, and 3. So down F, A, E, the center point O, B, D, and C. Got it? So now it will come in a vertical plane as dash 6 dash 1 dash 5 dash 2 dash 4 dash 3 dash. Wherever the lines are joined, we just mentioned it. So this is the front view and top view as per the dimension given on the problem. Now we are, if it is inclined 45 degree from the front view, from the vertical plane, how it could look like. For that I have to draw first 45 degree, sorry, okay, this faces is 25 and this height is 60 mm. Okay, so the base is 25 mm and the height is 60 mm. Next I have to draw a 45 degree line from vertical plane. I have to draw 45 degree line from the vertical plane. That will be the 45 degree, and parallel to same line I have to draw another center line, and then perpendicular to the center line I have to draw lines like this, inclined lines from HP, from horizontal plane, and same way from down also. Okay, the same way from down itself. Okay, now I will get a view like this. 25 mm, 25 mm, straight line, 25 mm, 25 mm, straight line, then inside 25 mm, 25 mm. I cannot see it, that's why it could be on dotted line. I can see it and I cannot see it. Okay, so this is the ends. We came to end, mostly end of the drawing. See again, here only one thing I haven't mentioned here. What this one? Okay, so here if it is going from here, this comes as F1, F dash, A dash, E dash, B dash, D dash, C dash. From wherever the line is going, just mention the points. And here it come 6 1 1 A1, F1, E1, O1, B1, D1 and C1. Okay, this you have to mention by looking at the diagram. That one you know already. You have if you know the orthographic projection clearly, you can mention the points here very clear. Okay, so be careful about that. This again I'm telling, I haven't mentioned here, I haven't drawn with any right measurement. Roughly I taken measurement and roughly I have drawn my own length. Okay, but the procedure is this, the method is this only. Whatever the sum may be, the procedure is the same like this, how to you are going to draw it. Okay, so 45 degree, this the other 60 mm and 25 mm, this base must be 25 mm, be careful about that, and this height of the axis length must be 60 mm, be careful about keep rightly 60 mm, and joining lines, inclined lines, just keep it carefully, and from where I have to take the 45 degree, that I have to be careful. This everything. Okay, so these are the main things of the axillary views of projection. Okay, axillary views projection. This is the second lecture, this fourth lecture and the second drawing of axillary views chapter. Okay, the next. So this is summary. So we have discussed about the problem solved on axillary view projection. This is the second problem we have solved here. So I hope that you may understand very clearly. I think I have given my best. I can't do more than this. I given my best of in this in this video, that you can draw it clearly and perfectly also. Okay, On the next class, we are going to see the third problem of auxiliary view projection, and it will helpful for you also. And we will see different shapes. Okay, we are on the next class. We are going to see the different shapes, so it may be give you a different ideas also. Okay, and at last, I would like to. This is the and the reference book is Engineering Graphics, topic on auxiliary views. You get more problems, more drawings in that also, and engineering drawing by Joel Hay. Okay, and I would like to thank you all at the end of this session, this video. I will meet you on the lecture 5, auxiliary views drawing, with the third problem in with a different object. Okay, thank you once again.